Okay, so Friday we talked about probability questions with the word or in them. We talked about something being overlapping or disjoint. We talked about how when you put an or in a problem, it actually encompasses more items typically. Like if I said, raise your hand if you have a dog. Raise your hand, keep your hands up. Raise your hand if you have a cat. Keep your hands up if you have a dog or a cat, either or. There's lots of hands in the room. Now only keep your hand up if you have both a dog and a cat. See, when we said and, hands went down. We said and, hands went down. Because only some families have both of those pets. And means both things are happening. Or means it could be either. The dog owners and the pet owners. So when there's or in there, we actually we add probabilities together. We combine them to make one whole probability instead of multiplying. So the word or is significant. It changes the math operation. Or and some words for there's a lot of words for and, like also both. I wonder what some words for or are. I'll have to keep an eye out when we read. All right, I'm headed to page 784. Somebody's talking. You know what? I did face cards in first period. I said ace was not a face card. Double check right now. Do you guys think ace is a face card? No, it doesn't have a face on it. It's annoying to put a problem in a math book that doesn't have like definitive. Yeah. 42.3. I just don't know. But I'm gonna tell you, rolling my face. What am I doing? You want it? Let's see if I make it happen. Card is 13 out of 52. How many face cards are there? There's either 3 times 4, which is 12, or there's 4 times 4, which is 16. And then how many cards are both heart and a face card would be 4. 48. 42 with the ace. 42, yeah. I'll read it. Did you ace in their face card win? So you did 12 out of 52? You did 25 and then you took 3 away. Yeah, that's it. So, I just wanted to double check. Including ace as a face card, guys. So your face is Jack, Queen, King, and literally those are the only ones with faces. So, and I picked cards because a lot of people are saying, man, I haven't picked cards that much. I find these more difficult. So, all right. So a heart. So we're gonna call the probability of a heart event A. And there's a 13 out of 52 chance of pulling a heart out of the deck. Now for a face card, we'll call that event B. We're only going to count Jack, Queen, King. So that's 3 faces. I keep wanting to use like an old school times thing. Times 4 suit.
Why not use the old school?
Because it's an X. And that's a 12. So there's 12 out of 52 face cards. So the probability of A or B would be all of the hearts plus all of the face cards. But we have some duplicates in here. Okay? The Jack of Hearts is being counted in both of these categories. And that makes it seem like you could pull a Jack of Hearts out twice, which is not the case. There's only one Jack of Hearts in there. So we have to subtract the duplicates. Subtract the overlap is the vocabulary from Friday. So how many cards are both heart and face? Jack of Heart, Queen of Heart, King of Heart. So that's 3 out of 52 have been counted twice. And that's going to give us our answer. 25 minus 3. 22 out of 52. And with your work today, you want to answer everything in simplest form so that those both divide by 2. So that's 11 out of 26. And divide it out, and it's approximately 42.3%. So the chance of you getting a heart or a face card is really, really high. I mean, it's not likely, but it's getting close to 50% of all the face cards and all the hearts. There's almost just as many face cards as a whole suit. So, okay, I feel I should pause now and let you continue number 8. Find the probability of a 10. Find the probability of a diamond. Add them together, subtract the overlap. Are you done, Annalise? Have you done 8 yet? Maybe I have one you could borrow. William, you finished 8? Yeah, you got 7 right away. He called 7's answer out right away.
It's not right.
He's working a lot harder today, too. Do you want to do this one out loud, Keith?
I sure will.
How many 10s are there in the deck of cards?
There are 4 10s.
Okay, so the probability, oh my gosh, the probability of event A, which is selecting a 10, is 4 out of 52. And the probability of event B, which is selecting a diamond, 13 out of 52.
So, and then minus 1. Okay.
Yeah, so the probability of A or B would be all 4 10s plus all 13 diamonds. That's 17. But we have to take away the 10 of diamonds. It was counted twice. So subtract overlap. That's the 10 of diamonds that has been counted for both criteria. And our answer is 16 out of 52. Which, both of those divide by 4. 4 out of 13.
And that is going to be about 20, 30, between 40 and 30%. No, 20 and 30. Ooh. I didn't know that. Yeah, I did it.
That's a quick estimate. Yeah. That's a really good job. You have about a 30% chance of getting either a 10 or a diamond. Now, real quick, let's say it was an ant. What's the probability of getting a 10 and a diamond? And you only can pull one card. What's the probability to get a 10 and a diamond? 1. There's one of those. 1 out of 52 is both a 10 and a diamond. So and is restrictive. Or is all of them. So one little word in there changes everything. All right, this one. I feel like we should look at the example before we get into this one. Let's go ahead and read example 4 because this next problem is a little bit tricky. An archaeology lab receives 150 artifacts for processing. So I'm gonna go ahead and identify that as the total. Helps me with the word problems like this. Of those, 100 are either made of clay or have coloring. 81 are made of clay. So this is a part. We have a total and we have a part. 34 are made of coloring. That's another part. What is the probability that a selected artifact is made of clay and has coloring? Oh boy. So what do we have here? Out of the 150, they have added the clay and coloring and arrived at 108 over 150. Added both the parts together and subtracted the 108 with the and. I don't know, they keep changing up the order of these problems, so read example 4 for a moment and then try number 9. I think somebody's out right now. Yeah, I actually think someone's already asked. Is it you, Sebastian? Yeah, so you'll be third in line. So I add up the parts. I will then subtract the one that says how many kind of students are totally in the sample space. Well, about 200, reduce it. 3 out of 50, divide it. And we're at a 6%. I don't feel like very confident in explaining it. That's how you do it.
I'm so sorry.
Okay, does anybody want to ask a question about Friday's assignment? 1, 2, 5 through 10, 29, and 31. Does anybody need to turn these on a paper? If I recall, we had like early finishers Friday, so. But if you want to ask a question, please do it. If you need to turn it on paper, please do it. Your assignment is not that one.
I don't know where that. I literally was just trying to do it. It's so silent. It's literally.
You're working today on page 786. Oh, we already did 10. Right. 11 through 16 and 18. We got lots of time to do it. I'll make it available online in about 10 minutes. You